Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of circles with examples. For this lecture, I am using the work of one of my best students, Miss Sayyida Fiza of class 2020, the Lyceum. An important advice for me and for everyone: we should be kind and we should be honest. Equation of circles. This is the standard equation of circle in completed the square form with center at A and B and radius R. And this is the way to get this equation. This is the center of the circle and this is the chord PS. And this Q is the midpoint of this chord, because when you drop a line from center to chord, then that line always divides the chord into equal parts and makes 90 degrees with the chord. In fact, this line is known as the perpendicular bisector of this chord PS. This point P has coordinates x and y, whereas this point Q has coordinates x comma b, because the y coordinate of center is b and this line is horizontal, so the y coordinate of Q is also b. This is a, this is x, so this distance must be x minus a. This is b and this is y, so this distance must be y minus b. So by using Pythagoras theorem into this triangle, we can get this equation of circle. So this is the way to get equation of circle in expanded form. Examples. State the center and radius of each of these circles. So to get the center and radius, we need to compare this equation with the standard equation of circle. So by comparing these two equations, we have A2, B4 and radius is 10. So the coordinates of center are 2, 4 and radius is 10. By comparing this second equation with the standard equation, we can get the values of A and B. So A is 1, B is negative 8 because of this sign is plus and this sign is minus. So minus B is equal to 8, therefore B is minus 8. So center of this circle is at 1 minus 8 and radius is under root 12, which can be written as 2 root 3. Similarly, while comparing this equation with the standard equation, we can get the coordinates of center, which are 0, 0 and radius 3. So with the help of this equation, we can write the equation of circle with center at origin and radius r. So this is the equation of circle with center at origin and radius r. You need to learn this equation and this equation by heart. Next example. Find the equation of each of these circles. Since center of this circle is at origin, so we will use this equation to find the equation of this circle. We just need to put r here, 8 square. So this is the equation of circle with center at origin and radius 8. Since center is not at origin, so we will use this equation to find the equation of this circle. So we need to put a here. When we will put b, we will write plus sign here because this is negative. So it will become x minus half, y plus 3 upon 2 and 5 upon 2 square. This is the equation of circle with center at this point and radius 5 upon 2. The equation of circles in expanded form. When we will expand this equation, we will get this equation. By replacing a by minus g and b by minus f and this entire thing by c, we can get this equation. So this is the equation of circle in expanded form with center at minus g and minus f and radius is C, I mean uh, G square plus F square minus C, because A is G, I mean A is minus G square, so it will become G square. Let me explain this here. Since A is replaced by minus G, so this will become minus G square. This is minus F square, R square C. So when you will make R subject, you'll get this thing, G square F square minus C. So this is the way to get the radius from this equation. So finally we have this expanded form of the equation of circle with center at this and radius is this. We just need to learn this equation as well. So we have three equations of circles. See, equation number 1 in completed the square form with center at A and B and radius R. Equation 2, standard equation of circle with center at origin and radius R. This is the expanded form of the equation of circle with center at this minus G and minus F and radius is this. But in all three equations, make sure the coefficients of x must be 1. If not, then you have to make them 1 by taking common. You need to learn all these three equations by heart. This is the example of the expanded form of the equation of circle. Since this equation is in the expanded form, therefore we need to compare this equation with this equation to get the coordinates of center and radius. So by comparing the coefficients of x of both the equations, we can get the value of g, which is 5. And by comparing the coefficient of y of both the equations, we can get the value of f, which is minus 4, and c is minus 40. And this is the formula of the radius. By substituting the values of g and f and c here, we can get the radius. So we had to find radius and center. Center is here and radius is here. What if we had to find equation of circle as well in completed this square form? Then we just need to put center and radius into completed this square form, into this form. This is an extra work. If the question is find the equation of circle or express this equation into this form. So to express this equation into this form, we need to substitute the coordinates of center and radius into this equation. We need to substitute this here and radius here. Angle properties of circles, which you have done in your O-level math syllabus D. These properties are very important to understand this topic. Property number 1. You all know when we subtend angle to the circumference from the diameter, from the end points of diameter, then we get 90 degree. And this property is known as right angle in semicircle. So whenever we have 90 degree on the circumference, then these 2 points, the end points of this line will be the end points of diameter. Like this line is diameter of the circle. And the midpoint of diameter is always the center. Property number 2. Tangent is perpendicular to radius. So if we know the gradient of this line, we can easily get the gradient of this tangent. And if we know the coordinates of this point, we can get the equation of this tangent. Property number 3. You all know the perpendicular from center to chord is always bisector. OM is the bisector of the chord AB. So center always lies on the bisector. So if any line is the perpendicular bisector to the chord, then center of the circle must lie on this line. Center always lie on the perpendicular bisector of the chord. Number 4. Tangents from external point to the circumference of circle are always equal. PA is always equal to PB. And these 2 triangles are congruent. meaning every corresponding thing of these two triangles are same. Every corresponding thing is same. This angle is equal to this angle, this angle is equal to this angle, these two lengths are equal, these two are equal because of the radius, and these two angles are 90 degree because these two triangles are congruent. Application of property number 4. See, if we drop a chord, if we make a chord from, this chord AB, then this angle is 90 degree. See, if we make the chord AB, then this is 90 degree because center to chord line is always perpendicular. And this is the midpoint of this chord. Important concepts. If ABC are joined to form a triangle with angle B is 90 degree, then AC will be the diameter of the circle. See, if this angle is 90, then AC will be diameter of the circle and the midpoint of AC will be center of the circle. Number 2. The equation of the tangent to the circle with center at this and at the point 6 minus 6. Since we have the coordinates of center and this point, we can easily get gradient of this line. And since tangent is always perpendicular to radius, so we can get the gradient of this tangent. The gradient of this tangent must be 3/4. Now we have the point, we have the gradient, we can easily get the equation of this tangent. Next. A circle passes through the points A and B. The point C is the midpoint of AB. Find the equation of the circle that has center C. So C is the center of the circle and midpoint of AB. Therefore, AB will be diameter of the circle. So we just need the coordinates of C, and we can get the coordinates of C by finding the midpoint of AB. And radius will be half of AB, or it should be just CA or CB. So we can get the equation of circle by finding the midpoint of AB and radius. Next property and concept. If 3 points lie on the circumference, like this, A, B, C. If 3 points lie on the circumference of a circle, then the center of the circle will be the point of intersection of the perpendicular bisectors of any two chords. If we make these two chords, then this is the perpendicular bisector of chord AC, this is the perpendicular bisector of chord AB. Therefore, center is always the point of intersection of these two bisectors, because center always lies on the perpendicular bisector of the chord. So you just need to make any two chords. So if we have 3 points, just make any two chords, like either AB or AC or AC or BC, and then draw their perpendicular bisectors. And center will always be on the bisector. Center is the point of intersection of both the bisectors, and radius will be either this distance or this distance or this distance. Center to circumference distance is known as radius. So examples. Number 1, find the equation of the circle that has AB as diameter. Therefore, midpoint of diameter will be center of circle. So we can get the midpoint, and this will be the center of the circle. And radius will be either this distance CA or CB or half of AB. So I'm finding CA. So radius is under root 8 and R square is 8. So by using this is completed the square form of the circle, we can get the equation of this circle. 5 minus 2 and 8. R square is 8. When you will put minus 2 here, it will become plus 2. So this is the equation of the circle in completed the square form with center at this point and radius is r square is 8. Number 2. A circle passes through 3 points. Find the equation of the circle. We have done this concept here. 3 points. Whenever we have 3 points on the circle, we will draw any 2 chords and then we will draw their perpendicular bisectors. And the center will always be point of intersection of the bisectors. So this is an important question. We have 3 points. So we can draw any 2 chords. OP, PQ or OQ, any 2 chords. So first draw any 2 chords and then draw their perpendicular bisectors and find the equations of these 2 bisectors. To find the equation of this bisector, we first need the midpoint of this chord OP, which is this. And then we need the gradient of OP, which is 3, and the gradient of bisector will be 1 minus 1 upon 3. The inverse reciprocal of this gradient. Now we can easily get equation of this bisector. We have the gradient, we have the point. This is the way to get the equation of this bisector. Similarly, we can find the equation of this bisector by finding the midpoint of PQ first and then gradient of PQ. So the gradient of bisector is minus 4. This is the equation of this second bisector. And center always lies on the point of intersection of these 2 bisectors. So by solving these 2 equations simultaneously, we can get the coordinates of center, which are 9 and 2. And radius is anything, either OC, PC or CQ. This is simple. By finding the length of OC, we can get the gradient. We can get the radius. So we have the center, we have the radius, we can get the equation. Concept: when 3 points lie on the circumference of circle, then draw any 2 perpendicular bisectors of the chords OP, OQ or PQ and solve the equation of those bisectors to get the center. You can take the screenshot of this solution because this question is very important. Number 3. Find the equation of the circle that passes through the points A and B and has its center lying on this line. So, center always lies on the perpendicular bisector. This is the first thing. And center, it is given center is also lying onto this line. So we just need to solve the equation of the perpendicular bisector of AB and this line simultaneously to get the coordinates of center. So first we need to get the equation of the perpendicular bisector of this chord AB. This is the chord, this is the perpendicular bisector of AB. This line is here. This is the rough sketch. So center is the point of intersection of this line and the perpendicular bisector of AB. So by solving this equation and this equation simultaneously, we can get the center. So first we need the equation of this bisector. And for that we first need the midpoint of this chord AB. This is the midpoint. And gradient of AB is minus 1, therefore gradient of bisector will be 1. The inverse reciprocal of minus 1 is 1. And this is the equation of this bisector. Now by solving this equation and this equation simultaneously, we can get the coordinates of center, which are 5 and minus 3. For radius, we can either find distance CA or CB. So we are finding CB under root 40, so r square is equal to 40. So this is the equation of this circle in completed the square form with center at 5 minus 3 and radius is under root 40. Must remember that center always lies on the perpendicular bisector of AB. Next example. The points P and Q lie on the circumference of a circle. Show that the center of the circle lies on this line. So this is PQ And first we need to find equation of the perpendicular bisector of PQ, because center always lies on the bisector of PQ. So midpoint of PQ is this, gradient of PQ is 1 upon 2, therefore gradient of this bisector will be minus 2. By finding the equation of this bisector, we can easily prove this thing. So in fact, we had to show that this is the equation of this bisector, because the question is the points P and Q lie on the circumference of circle, show that the center of the circle lies on this line. Therefore we had to show that this is the equation of the perpendicular bisector of PQ, because center always lies on the bisector of the chord. Next example. Find the equation of the circle that touches the x-axis and whose center is at 6 minus 5. This is the rough sketch. Since x-axis is tangent, because circle touch the x-axis means x-axis is the tangent to the circle. Therefore, since center has this coordinate 6 and minus 5, so this point has coordinate 6 comma 0. And this should be minus 5, and this length is the radius, because this distance is 5, so radius is 5. So we have coordinates of center, we have the radius, we can easily get the equation. The important part of this question is this: circle touch the x-axis, that means x-axis is the tangent to the circle, and this x coordinate of center is 6, so this must be 6 comma 0. Now these are the questions from past papers. Well, I will discuss these questions in my next lecture, inshallah. I hope this lecture will help you all to understand the important concepts of circles. An important advice for me and for everyone: we should be well mannered. Good luck and Allah Hafiz.